Hello everyone. Welcome to this course on programming for everyone. As the name suggests, all the modules have been simplified by correlating programming terms with real-world examples so that anyone can understand the terms without any prerequisite knowledge of technology. Also personally, it has always been my goal to evangelize technology to the common man in a language that he understands. Before we get into this module, let's start with some introduction. I am Arun. I am a freelance consultant, architect and a mentor for the past 3 years. Before this, I have worked with Wipro and Infosys for about 18 years after completing my degree in Electronics and Communication Engineering back in 99. Before we proceed further, let me throw some light on the key takeaways of this module. By the end of this module, you will learn about what is programming, why do we program, how is it helped us over a period of time, how to think like a programmer. A programmer is one who can break a task into smaller meaningful events. Get a feeling. It's no rocket science and anyone can do it. And finally, some assignments for you to actually go around and gather information on how to become a better programmer. Welcome to this first session. What is programming? The process of creating a program is called programming. In general terms, program is a series of events put together in a meaningful order. For example, a school's annual day program would be probably split into the following events: an invocation, a welcome speech, a guest introduction, so on and so forth, and finally ending with the vote of thanks. Here every event is triggered or started at the end of the previous event, and the flow depends on the requirement of the school. It's not so different in the computer world as well. A program is an executable software that runs on a computer, or a program is a set of instructions, subprograms or functions put together in a specific order. It consists of smaller events that we call subprograms, modules, functions and so on and so forth. It is quite easy, isn't it? The flow of order of the smaller events to the deepest details is called a flow of a program, or we call it algorithm. This can also be picturized as a flowchart. Remember the terms algorithm and flowchart. These will be very helpful as we go further. Now let's dig a bit deeper. In an annual day program, annual day itself is the program. So there are events within this. So for example, the event invocation is a subprogram, and this subprogram can be further divided into smaller events like lighting a lamp and a prayer. These are two instructions or commands or even smaller subprograms called functions in the subprogram itself. Program modularity. Program modularity means breaking the program into events called modules, which makes it easier to replicate, reuse the results or the functionality elsewhere in the same or a different program. So it is also called a function. For example, in any program, when the event invocation is present, the invitees know what is expected out of the event or what is the function of the event. The function has a defined set of input and outputs. However, the internal logic could differ. Breaking the program makes it easier to change subtasks, instructions in the event or the functions without impacting the entire program or the outcome of that event. Taking our previous example, the invocation event can be structured in 3 ways: lighting the lamp first, then the prayer first and then lighting the lamp, both together happening at the same time. As you can see, the order of the event in no way alters the entire program. In computer terms, this is called a program being modular. Changing a part or of a subprogram does not impact the functionality of the entire program as long as the input and output, in other words, the functionality remains the same. Why does a program needs to be modular? Consider the three options of invocation event. The options of doing both together reduces the time of the event as two subsequent events happen in parallel. Similarly, we can run multiple instructions in parallel in a program or a subprogram as long as they don't depend on each other. In computer terms, this is called parallel processing. This helps us do things faster and use time and resource more efficient. Before we end this first session, I would like to mention something about automation. Automation is the buzzword of the century, though it started during the time of Industrial Revolution. Automation is a process of handing over or transitioning a process or a part of a process that was, is or would be done by humans manually to a machine. And machines understand instruction sets which are nothing but programs. Automation is nothing but programming. In fact, programming can be called as a subset of automation. Automation helps us reduce human effort which can be used productively elsewhere and also reduces issues that are caused by human errors. So now we know what is automation. This brings us to the end of module 1, what is programming. In the next module we will see why do we program, what triggers programming, and what are the requirements around starting to program. Before we end this module, I am going to give you some assignment. Please Google around and find more details about flowcharts and algorithms. Find out more about threads and processes, multi-threading and multiprocessing. This we will use as we go on further deep and start programming. Goodbye till then. See you. Thank you.